There are few sounds more pleasing to an aviation specialist than the quiet hum of a well-maintained aircraft. The subtle noise indicates that propellers and rotors are balanced, plus vibration and noise are minimized, so flight is smooth and peaceful. But the benefits of balancing go beyond what is seen, heard, or felt. A properly balanced propeller or rotor reduces instrument, avionics, and engine wear, helps to prevent catastrophic engine failure, and prolongs aircraft life. Balancing helps ensure that flights are not only smooth, but also safe. Everyone knows that proper balancing and good maintenance takes the right tools, and that's something we take pride in at ACES Systems, creating better aviation maintenance solutions. All products in the ACES Systems family share the common traits of ease of use and versatility. Our products measure engine vibration, noise levels, monitor and trend engine performance, as well as perform dynamic propeller balancing and rotor track and balancing. The ACES Systems Model 2020 Pro Balancer Analyzer is a visionary tool for performing propeller balancing and rotor track and balancing. This tool is easy to use. On-screen instructions step you quickly and easily through balance jobs, so you need little to no training in propeller or rotor balancing. Beyond simple balancing, the Model 2020 offers the advanced feature of full spectral analysis, allowing you to view a wide range of minute frequencies for all rotating components. The Model 2020 also accepts data from 2 channels simultaneously, allowing you to compare vibration frequencies from 2 propellers or rotors, facilitating and increasing the accuracy of balancing. The remainder of this video will step through the operation of the Model 2020 Pro Balancer Analyzer. Part 1 will concentrate on balancing. Part 2 will be an overview of how to use the instrument for spectral analysis. This video presents only the basic steps needed to get you up and running. The video cannot replace the detailed information found in your user's manual. Refer to it frequently to help you through the process of performing propeller or rotor balancing. Before beginning, it's important to familiarize yourself with your new equipment. The Model 2020 Pro Balancer Analyzer comes with these basic accessories: the Model 2020, a battery charger, a communications cable for connection to a printer, computer, and a user's manual. The Model 2020 Propeller Balancing Kit includes the basic accessories just described, plus everything else you'll need to do the job: the Phototach speed sensor, the Phototach mount assembly, reflective tape, and the 25-foot tachometer sensor cable, the 991 vibration sensor, the 1/4 by 28 vibration sensor mount, an 8-piece case bolt adapter set, and the 25-foot vibration sensor cable. The Propeller Balancing Kit also includes a pocket Pro Tackle box, a protractor, a digital gram scale, the FAA-approved ACES Systems Guide to Propeller Balancing, and this training video. Now you're ready to begin. Before you start the balance job, complete an inspection of the propeller assembly in accordance with the ACES Systems Guide to Propeller Balancing. When the inspection is complete, you are ready for the equipment setup. The first step is to install the Phototach to the aircraft. About a foot from the back surface of the target blade, install the Phototach at a selected clock position. Remember this clock position for later entry in the setup. A 5-degree angle perpendicular to the target blade produces the best result. Use speed tape or duct tape to secure the base mount to the cowling surface. Attach the tachometer cable to the Phototach connector. Route the cable away from hot areas and electrical equipment into the cockpit. Attach to the tach channel according to the application. If balancing 2 engines, it is best to attach to the channel number matching the engine number. Remember the selected channel for later entry in your setup. Secure the cable route with duct tape or tie wraps. Pick a point on the back side of the target blade to place the reflective tape. Hold about a 2-inch strip of reflective tape in position on the propeller blade. Visually align the tape with the Phototach lens. Clean the area where you intend to place the reflective tape. Note the position and remove the backing from the tape. Install the tape and smooth out edges and any bubbles under the tape. Standing forward looking aft, install the vibration sensor and note the clock position for later entry in the setup. Use the case bolt adapter and sensor mount found in your kit as necessary. Attach the vibration sensor cable to the sensor connector. Route the cable back to the cockpit, avoiding hot areas and electrical equipment. secure in the same manner as the tachometer cable. Attached to the sensor channel specified. To start a balance job with the model 2020, you must first load a setup. A setup is information stored in the analyzer's memory for rapid configuration. To accomplish this, first turn the analyzer on. Use the up and down arrows to navigate the screen until the selection Propeller Balance is highlighted. Press Enter. The screen will display the Propeller Balance banner across the top. Select Manage Setups by using the up and down arrows and then press Enter. The Prop Balance Setup screen appears. Select and press Edit. Default values in some fields appear automatically, but can be changed to more appropriate data. Enter a name for the setup by using the analyzer keypad. Let's say your plane is a Warrior, and that's the name you've chosen for your setup. The letter W is the third option on the key. Press the key 3 times rapidly, and the letter W appears in the name field. Wait 2 seconds and enter the next letter. In this case, the letter A is the second option on the key. Press the key 2 times rapidly and wait 2 seconds. Proceed until the correct name appears on the screen. If you make a mistake, use the right and left arrow keys to position the cursor to the right of your mistake. Press the clear key, then select the correct letter. Use the down arrow to progress to the next field, engine horsepower. Use the keypad and enter the rated horsepower of the engine. The balancing RPM is the speed at which you intend to balance. A low cruise RPM is best. Enter the low cruise speed or the speed at which the noise and vibration complaint occurs, whichever you feel is more appropriate for your aircraft. In the max balance weight field, enter the maximum amount of weight allowable for that propeller. Refer to the ACES system's Guide to Propeller Balancing for this figure. Beginning with the next field, Number of Engines, note that the entry boxes for the rest of the screen have pointed ends. The information for the pointed end boxes cannot be entered from the keypad. Instead, use the right and left arrows to navigate to the most appropriate selection. A default number of 1 appears in the Number of Engines field. If you're balancing 2 engines, press the right arrow. After you press the down arrow to leave the field, the remaining fields automatically make the appropriate changes to accommodate 2 engines. The direction of rotation is from a viewpoint of forward-looking aft, FLA. The rotation field is set at the default direction of CW for clockwise. If incorrect, press the right arrow. Your propeller balancing kit includes an optical tack. For the tack type field, use the right and left arrows to select optical, unless you're using another type. Tack channel corresponds to the tack input port from the tachometer used for balance. Choose either 1 or 2 if balancing a single engine. If balancing 2 engines, channel 1 defaults to the number 1 engine and channel 2 defaults to the number 2 engine. Tack position FLA indicates the orientation of the tack sensor you're using as compared to hours on a clock. Tack position is viewed forward looking aft. Use this physical position every time this setup is used for balancing to shorten the number of runs required. Use the right and left arrows to navigate to the correct hour corresponding to your tack position. Select sensor type from the list of sensors in the sensor directory. If your sensor is not included, refer to the user's manual for directions on how to add your particular type sensor to the directory. For the sensor channel field, pick either A or B unless you're balancing 2 engines. With 2-engine balancing, A defaults to the number 1 engine and B to the number 2 engine. If performing a dual rotational plane balance, navigate to select A and B, with A as the front sensor and B as the rear sensor. Sensor position FLA is determined in exactly the same manner as the tack position FLA. After all fields are correctly entered, press the Enter key to accept and store the setup data. Next, from the main menu screen, select Propeller Balance and press Enter. From the Propeller Balance screen, select Start a Job and press Enter. From the Start a Job selection, the setup list will appear on the screen. From the setup list, select the setup you entered. The customer information screen appears. You have an option to fill in this information or simply to press the Enter key to bypass this screen. The engine information screen appears. Record the information or press the Enter key to bypass. The propeller balance equipment setup screen is displayed. This screen directs you to install the tach and vibration sensors you specified during setup. If the equipment setup was previously completed, you need only verify tach triggering and sensor clock positions at this point. At the bottom of the screen, you'll see the tach on option. Press the F1 key to turn on the tach. Ensure mag switches are off prior to any movement of the propeller. Move the propeller blade with a reflective tape back and forth in front of the phototach beam. Use an inspection mirror to make sure the red LED gate indicator light on the aft end of the phototach turns on and off as the tape crosses the beam. If a positive tach trigger is seen, the phototach is operating properly. Before proceeding, make sure all trim balance weights installed during previous dynamic balance procedures are removed. Refer to the ACES System Guide to Propeller Balancing found in your kit for a full list of FAA-approved inspection requirements. With the sensor and tachometer installation complete, return to the cockpit and press Enter on the analyzer. The Start Aircraft screen appears. Start the engine according to flight manual procedures. Allow the aircraft to reach the normal operating temperature and press Enter on the keypad. The Set Engine Speed screen appears, displaying the run number and engine number. The next line indicates the RPM balance speed specified in the setup, followed by your current RPM. Adjust the throttle and/or prop lever so that the RPM on the two lines match as closely as possible. Press Enter and the engine number, run number screen appears. The current and average RPM frequency, IPS, and phase are displayed along with the percentage error in averaging indicator. When the percentage error reaches its lowest point, press the Enter key on the analyzer. The Review Job screen appears. IPS and phase, represented in degrees, are displayed for the sensor channels used. If you are satisfied with the run and ready for a solution, press Enter to accept. An information screen appears advising you to shut down the aircraft in accordance with the flight manual. Shut down the aircraft and press Enter to continue. The Balance Solution screen appears, advising you how much weight to apply in a specific location. Refer to the ACES System's Guide to Propeller Balancing found in your kit for specific guidance on installing weights and the Model 2020 User's Manual for directions on the use of the propeller protractor. Match the recommended weight as closely as possible and install the weight as near the suggested location as feasible. As exactly as possible, enter the weight and angle where requested on the screen and press Enter. The Start Aircraft screen appears. Follow the same procedure for your second run. Continue performing runs until you achieve a satisfactory result. Install permanent weights in accordance with the ACES System Guide to Propeller Balancing. Most maintenance personnel like to print the balance job for their permanent records. To print a report, press the main menu key on your analyzer, then select and enter the Miscellaneous Items subheading. Under Miscellaneous Items, select and enter Printer Setup for detailed instructions. After setting up the printer, press the main menu key. Connect the communications cable to the analyzer and the printer. Make sure the power is on for the printer and the analyzer. From the main menu screen, select and enter Prop Balance. From this screen, select and enter Manage Jobs. From this screen, select and enter the Print function. Select the job to print and press Enter. The analyzer screen indicates the status and when the printing is completed. Leave the equipment in place for Part 2 of this training, using spectral analysis. Using spectral analysis allows you to complete and store surveys using the setup feature. Several different components can be surveyed without manually entering the setup data between surveys. To begin, press Main Menu on your analyzer. Select and enter Vibration Spectrum Surveys. From this screen, select Start a Job. The Spectra Setup screen appears. Default values in some fields appear automatically, but can be changed to more appropriate data. Although name is an optional field, it's best to name each setup to differentiate it from other spectra you'll store in the future. Determine and enter the minimum and maximum frequency requirements. For pointed-end boxes, use the left and right arrows to navigate between selections. Choose either RPM or Hertz for your frequency units. Select and set the resolution field. 400 lines is adequate for most applications. For average type, navigate and choose between normal and peak. Blocks in average refers to the number of data blocks you want used in the calculations. Higher numbers provide more reliable data but require more time. Measure inputs determines from which channels the vibration data is acquired. Navigate among A, B, or A and B. Enter a defining name in Channel A description and Channel B description as necessary. Select and set the vibration field to the appropriate type of units for display on the amplitude or y-axis. Mod is an abbreviation for the unit modifier relevant to the unit specified. Navigate and choose the most appropriate selection. Full-scale vibration indicates the maximum amplitude you expect to encounter. Navigate and choose the selection that displays the full amplitude. Select among the choices in the sensor field until the desired sensor is displayed. Refer to your owner's manual to add additional sensors to this list. Press Enter. A screen appears asking if you'd like to store this new setup. Press F1 to accept and store the setup. The customer information screen appears. Entering this information is optional, but providing a customer name is recommended, as it will aid in identification of the job for resuming or reviewing purposes at a later date. Start the component you are checking and let it achieve normal operating conditions. Press Enter to begin acquiring data. When the spectra is displayed, observe the three boxes at the bottom of the screen. The first box, Options, corresponds to the F1 key. Press the F1 key and the boxes change to read Cursor, X-Scale, and Y-Scale. Press the F1 key again and the boxes change to Normal, Harmonic, and None. Press either the left or right arrow keys to produce a normal cursor, as well as an X and Y value readout box. Move the cursor along the X-axis using the right and left arrow keys. The value of both axes are displayed in the readout boxes according to the current position of the cursor. Press the F1 key twice, and then choose the key corresponding to harmonic, the F2 key. Multiple harmonic cursors appear to the right of the fundamental frequency. When the fundamental frequency cursor is moved, the multiple cursors automatically follow the movement and position at the new multiple. Press the F1 key twice, then the F3 key, and the three boxes return to the original names. Press the F1 key for Options, then the F2 key for X-Scale. The boxes change to read Expand, Default, and Shrink. Press the F1 key corresponding to Expand, and the X-Scale of the spectra enlarges. The three boxes at the bottom of the screen automatically revert to the original three choices, Options, Pause, and Restart. Press the F1 key, then access the X-Scale by pressing F2. Press the F3 key corresponding to Shrink, and the X-Scale of the spectra is reduced. The three boxes at the bottom of the screen automatically revert to the original three choices, Options, Pause, and Restart. Press the F1 key, then access the X-Scale by pressing F2. Access the default setting by pressing the F2 key again, and the analyzer returns the X and Y scales to the values specified in the setup. The three boxes at the bottom of the screen automatically revert to the original three choices, Options, Pause, and Restart. Press the F1 key, then press the key corresponding to the Y scale, F3. Here you can perform the expand, default, and shrink functions for the Y-axis in the same manner. After finishing, choose the key corresponding to pause, F2. Pressing the key stops data acquisition and freezes the screen with the latest displayed data. Press the key corresponding to resume, which is F3. The model 2020 will acquire additional data. Anytime the spectrum is displayed on the screen, you may press Enter to terminate data acquisition. To print your vibration spectrum surveys, follow the same procedure for printing balance reports. Spectral analysis can seem intimidating at first, but it isn't difficult once you understand the basic concepts. ACES Systems offers extensive training on spectral analysis as well as other applications to help you use this versatile equipment to your best advantage. Please contact us if you have questions or would like information on additional training. At ACES Systems, our goal is to provide you with the equipment and the knowledge to quickly and efficiently analyze, balance, and monitor aircraft performance. The ability to observe and quantify engine vibration and noise levels allows you to trend engine performance, resulting in the safest, smoothest flight possible and prolonging the life of the aircraft. The Model 2020 ProBalancer Analyzer allows you to maintain your aircraft at optimum levels, and that's why we are here, to create better aviation maintenance solutions for you. ACES Systems.